All right, on this example, we have a nice picture given to us that accounts for most of this information. Basically, we have two guy wires that are both grounded at the exact same spot out here. That's 50 feet from a wall. One of them's up here 47 feet tall, and the other one's 40 feet tall. And our goal is to end up finding this angle alpha. All right, they've already told us beta is going to be the bigger angle going all the way from ground all the way up to this upper angle. But we want to find alpha here. All right, definitely a couple different ways you can go about this. The book goes about this slightly differently than how I do. So what I'm going to do is go ahead and I'm going to introduce one more additional angle. I'm going to call theta the lower angle, kind of like that connects up to that 40 feet tall in the air. All right, so the ground up to that 40 feet tall. So why I'm doing that is what I want to do is I can represent some of this stuff, right? We know that tangent of beta is going to be from SOHCAHTOA opposite over adjacent. All right, so that's kind of looking at the bigger triangle, right? The bigger triangle was 47 for the opposite side and 50 for the bottom, the adjacent side. And then we can also represent tangent of theta. I know I introduced theta to this, but I think that's okay. Again, that's an opposite over adjacent. But in our case, the opposite changes in this one because it's that smaller triangle that's 40 feet tall and 50 feet for our adjacent along the bottom. All right, that will reduce down, of course, but let's not worry about that for right now. Next, let's try to go ahead and represent tangent of alpha is going to be the same thing as the tangent of our bigger angle, in our case beta, minus our smaller angle theta. All right, so think about that. If we took our bigger angle and we subtracted away our smaller angle, what remains should be that alpha in the middle. All right, so with that in mind, and this being difference formulas, let's write that out as a difference formula. Using that identity, it's going to be tangent of beta minus tangent of theta over 1 plus tangent of beta multiplied by tangent of theta. All right, so from here, let's go ahead and start filling in those values that we identified up above, right? Let's make it all numbers, and then it's just a simplifying problem. So tangent of beta, we can replace with 47 over 50, minus tangent of theta was 40 over 50. And you may notice why I didn't reduce down, because I like that common denominator. And then we have what? 1 plus tangent of beta, again, 47 over 50. Multiplied this time by tangent of theta, 40 over 50. All right, from here, it's a lot of reducing because everything's just numbers now. We just need to do a good job of reducing and be careful. So for our numerator, we've got two fractions subtracted, but they already have a common denominator. So subtract those numerators, keep the common denominator. For our denominator, the big denominator, I'm going to first go ahead and multiply those fractions together. So 47 multiplied by 40 is 1,880. And 50 multiplied by 50 is 2,500. Okay, more simplifying. Let's rewrite that 1 that's hanging out in front. So it has a common denominator. All right, so let's give it the same denominator, 2,500 over 2,500 plus 1,880 over 2,500. Got to get that same denominator before you can add them together. But now that we have it, let's go ahead and simplify that denominator further, keeping the common denominator of 2,500. We're going to go ahead and add 2,500 plus 1,880. Works out to be 4,380. Okay, from here, I'm going to go ahead and let's multiply by the reciprocal of the denominator. So I learned this initially as keep, change, flip, but instead of dividing one fraction by another fraction, let's go ahead and multiply by the reciprocal of that bottom fraction. So I'm flipping it upside down, basically multiplying both numerator and denominator by 2,500 over 4,380. All right, this will reduce some, because 2500 was 50 multiplied by 50. So we have a 50 being multiplied in the numerator and a 50 multiplied in the denominator, so that'll at least reduce down some. Now let's go ahead and multiply. We have 7 times 50 is 350 for our numerator, and 4380 for our denominator. All right, definitely both multiples of 10, so I'll take that out. But when it comes down to it, we are going to have to pull out our calculators at some point. Remember, this was tangent of alpha initially is equal to what we ended up with. So to get alpha out from inside of that tangent, we're going to need to apply a tangent inverse to both sides. So as we do that, tangent inverse gets applied to both sides. A lot of just writing out the exact same stuff, but that'll get us alpha outside, right? It's no longer stuck inside of tangent or tangent inverse. And now all that remains is basically get this in your calculator. Now we can be either in degree mode or radian mode. They didn't really tell us. If we're in radian mode, I got 0.0797, and this keeps going. I just did some rounding here, but that'll be in radians. Or in degree mode, I got this to be about 4.57 degrees. So just be careful which mode you're in. Will predict if you get radians or degrees coming out at the end. All right, there's definitely a different way to do this without introducing theta, an additional angle in there. I just find it to be a little bit easier if we do use theta involved here, because setting up those initial ratios where you can get tangent of beta and tangent of theta pretty easily from the beginning, I think makes this pretty easy work. But, you know, do it however you want. As long as we're getting to the same answer, good luck.